Okay, Jag, you are on. Thank you so much.
Okay. Hi, everybody. Welcome to this first Ethical AI Forum that MIDAS is organizing, sponsored by the rocket companies who have been very dear and helpful partners in many ventures that we've been doing over the past period. I'm H.V. Jagadish. I'm the director of the Michigan Institute for Data Science. We in MIDAS try to promote data science and artificial intelligence work across the university, both the development of cutting-edge methods and their use for in a number of disciplines. I was hoping to be with all of you there today, but even though the COVID pandemic is officially over, it has forced me to be in a situation where I have to isolate from home. And so I'm just a couple of miles down the road from all of you, and will be quietly listening in online instead of being able to interact with you. But I'm really looking forward to the day, and I hope that all of you have a stimulating conversation. We have a fantastic lineup of speakers. And with that, I'd like to hand this off to Brian Stuckey, I suppose.
Right. Thank you, Jag. Let me know when we get the slide deck up there. Great. Thank you very much. My name is Brian Stuckey. I lead the Rocket Ethical AI team at the Rocket Companies. Like Jag, unfortunately, I had planned to be there in person with you today, but a rather unfortunate series of, shall we say, flight incidents beginning Sunday did not allow me to get from Virginia to Michigan. I am happy to report that my checked bag did arrive safely in Detroit last night, but I am back here, joining you all in spirit at least. Go to the next slide. The slide here to show you our team. You will get to meet all the rest of them there in person today and during the rest of this presentation. I did want to call out in particular Bernardo Modenesi, our first Rocket Fellow, who organized this summit and has been just absolutely wonderful to work with, and has provided our team with some invaluable insights. And I also wanted to call out, not pictured here, countless stakeholders across the Rocket Companies that have been a tremendous help in our effort from the beginning. Our partners in legal, in enterprise risk management, government affairs, data science, data privacy and security, that have all contributed to what we're doing because they all play a very important role in this. This is something, when you're talking about responsible or ethical AI, does require, I believe, effort and input from multiple parties in any organization. So today, what I'm going to talk about here, just to give you a bit of an opening and a background for a few slides to set the table for our team and what we do, and then let the rest of our team members come up and show you our approach at Rocket and the ways we have considered ethical AI should be rolled out across an organization. So in terms of a quick overview here, you can pop up one more slide. You heard me mention the Rocket Companies. You probably have all heard about Rocket Central. about Rocket Mortgage. That is the primary Rocket company here. We have really diversified in terms of the portfolio of the activities and the business that we do. Our team is headquartered in Rocket Central, and Rocket Central was set up really as a central organization to serve as a consulting or a services arm for all the rest of the Rocket companies. So a lot of core functionality that benefits all of the Rockets is centered there. A perfect place for us in terms of what we are doing with respect to ethical AI. Now, on the next slide, I wanted to speak for a moment about what we look at as sort of the current state of AI and governance. For AI, this should be nothing that is new to any of you, but specifically with respect to lenders, business rules. Some of you may not necessarily put that in the AI bucket at the start, but it did come from the initial work on expert systems, and it has been prevalent in the mortgage industry for probably 30 years at this point. I would be hard pressed to name any lender that doesn't have multiple business rule applications in their organization. And Rocket is no different. Our core underwriting system has a very large business rule implementation. Ultimately, we moved into areas of machine learning when data and computing power became more available, natural language with respect to chatbots. And I think you will find most of the organizations that are lenders are looking at these techniques and approaches. And certainly now on the radar, generative AI at the top of everybody's list, both very excited about the prospects of what it can do and a little frightened in terms of what it can do and how we can watch over it. Now, on the other side of the table, we've got our sort of current regulatory state. We all operate under fair lending laws, which have been in effect for some time, which basically says we can't treat an individual differently, disparate impact or disparate treatment based on a protected class, gender, age, ethnicity. It is in place for the entire mortgage process. It covers how we market somebody, through how we will make a credit decision on the individual, all the way through to how we service them after. There is nothing specifically in place that regulates how AI or machine learning or generative AI can be rolled out and used. But we're seeing what I consider to be sort of a top-down approach from the government. NIST, the National Institute of Standards and Technology, has issued a AI risk framework that helps really provide a set of governing features if you're using AI. The White House posted an AI Bill of Rights during the fall. And I think there's actually been even more progress in the EU, first with GDPR, the General Data Protection Regulations, and now with their AI regulations, which they have scrambled very recently in order to include some provisions for generative AI. And really on the radar here, I would argue, is what's coming up from the states. Various states are taking a much more aggressive approach in proposing legislation for how AI machine learning are going to be rolled out in terms specifically of governance over the processes and in terms of ensuring that bias does not occur. There are still some very hard questions to be asked in terms of what is fair, what constitutes bias, but they are taking a very proactive approach in this. States like California, New York, New Jersey, Washington, Illinois have all got some sort of pending regulation out there. So there's a pretty big gap between what we can do and what we can regulate. And I think that gap right now can be filled and needs to be filled by responsible AI organizations. And we certainly hope that the companies like Rocket are taking this seriously in this respect. We've got a good idea of how to roll out an oversight and governance process generally. That notion has been around for a while in various facets. But currently, I think the real business is in transparency and explanations in systems and doing fairness evaluations and really having the techniques there to be able to assess whether an implementation is fair or not. And on the radar, not really sure where we will go next. I can tell you at Rocket, the last couple of weeks have been focused solely on what we do about generative AI. There are a lot of groups across the Rocket companies very interested in exploring this across a wide variety of applications, and how we can provide the oversight there is going to be a challenge, but something we're definitely very interested in and will follow up on. So the next slide, Lasty, is really just kind of summing up the way we believe an ethical AI or responsible AI group can be rolled out. As I mentioned, with Rocket Central, we serve as the hub for everything across all the Rocket companies. And our mission is simply that any automated decision systems built by the Rocket companies are necessary, of high technical quality, bias-free, and do the right thing. We have to ensure absolutely that we are compliant with fair lending as a baseline. And then the next step up, ensure that we are in fact doing the right thing. We are trying to work closely with government affairs to stay ahead of the pending regulations and ensure that if and when those come, we are ready to roll and ahead of the ball game there. And why do we do this? Besides being the right thing? Well, we want to minimize the likelihood of penalties, lawsuits, and reputational risk. To be honest, the regulatory penalties for something like this for a company the size of Rocket is really insignificant. It's not that much. The reputational risk is huge. And that's the thing that we want to present. We like to say that we work to ensure equality and strive for equity. And I'm sure this equity topic will come up during the course of the day, but ultimately we want to see if we can use the technologies we develop here to provide more ways for affordable housing and to reach underserved populations, because we know that has been an issue in the industry for a long time. Now, with that, I am going to turn this over to our team there in person, starting initially with Trevor Ferry, who will talk about our approach for governance.
Yeah, thank you, Brian. So our approach at Rocket is the Rocket Ethical Framework. As far as the governance goes, we need to ensure that what we have is going to be one centralized location that explains that we know fully what we're doing with our AI, how it was built, as well as then show all of the chain of custody and approvals in case a regulator in the future does need to see exactly what we did. So we call this the Rocket Ethical Framework. Essentially, how the Rocket Ethical Framework, or the REF as we call it, works is we collect all the data up front. We make sure that the data itself is as free of bias as it can be, that all of the privacy and permissible use of that data is handled properly before we even use it in a model that's going into production for our company. After that, we take a look at the model. We look at the different features and attributes as how it was built to ensure that there's fairness there. We're not using anything that's a protected class or very close in proxy to a protected class. We look at the different methodologies and explainability of how we can look at the outputs of the models to ensure that we're also seeing no unintended bias with how it was built and the collection of features that we have. And then when it goes into deployment, we want to make sure we can explain exactly how it's being used, exactly what purpose different teams throughout the company, from marketing all the way to servicing, are going to use the outputs of the model, assure that the outputs are lined up with our company culture and values as well, and then also ensure that we've got that reporting necessary all in one location so that we can completely show with pure confidence that we know what we're using, why we're using it, and that it is indeed free of bias. So taking a look at it, there's a few different steps that get us through this process. The first one is to collect that business use case so that we understand how they're going to use the model. This also ensures that when we're doing an evaluation for that fair lending process, that indeed we know what it's being used for and we're looking at it through the right different statistics and methodologies. The next part is we talk to our data science teams that built the model to ensure that we understand where the data is coming from, what went into the model, and what features and attributes they can use, can't use, have those conversations early and often. After that is when we get into the legal aspects of it. Like we said, the privacy and permissible use of the data that we have there, that everything's going to be compliant through our legal system. Then that's where our team steps in, where we actually take a look for that unintended bias through the model, able to explain what's happening, why we're seeing the outputs that we are along those protected classes to move right through. And then after that, we make sure that, again, our legal team in fair lending has seen what our analysis has shown, as well as that the business leaders that are going to be using the outputs of the model and the technical leads for the team that built the model are aware of what they built, the approval process it went through, and that they feel comfortable using it as well. With that, I'm going to actually pass it over to our data scientist, Lucia, so we can go a little bit into our methodology.
I have a quick question.
We'll have a Q&A at the end.
For my reference, protected class.
So protected classes would be along, and that's one of the slides we get to, but along sort of what the ACOA and the FHA have set up, so like age, race, gender, marital status, all of those typical things that you would see along there that are our fair lending concerns in the realm that the Rockets typically operate in.
You know what the term meant when you were using it?
No, absolutely, yeah.
Yeah, stole one of my slides, so thanks for asking. So I'm going to cover how we perform our analysis. So there's many sources of bias. This is not an exhaustive list, but just a sample of different ways that bias can find its way into machine learning outcomes. At Rocket, we focus on specific areas of bias. At the organizational level, we have an inventory of every machine learning model that has been or was ever deployed and understand how it's being used. And then we assess each model for different sources of the performance of each model in order to understand how bias might be affecting the model performance. That could come from bias that exists in the data or in how the model was created. Trevor already alluded to this, but we start with gathering context from our business partners, so understanding why are they deploying this model, what the goal is, and understanding why they picked the performance metrics or any analysis that they did on their performance before performing a fairness evaluation. That fairness evaluation is model agnostic, so really focusing on how the model performs with respect to protected classes, both in terms of outcomes or treatment, as well as scoring that the model has towards protected classes, and then partner with our fair lending legal team to come to a final conclusion of whether or not we feel comfortable deploying this model into use. So our team is mostly the data science and statistical analysis side of it, and then we lean on our legal partners for that legal interpretation of whether or not they feel comfortable, given our evaluation, with how the model is performing, and if we need to work with the data science teams to remove any bias that we might see in the model. And as you asked, there are many protected classes. The main ones we focus on are race, gender, age, and marital status from a regulatory standpoint. So we have some of that data internally as part of the Home Mortgage Disclosure Act. We are required to collect demographic data from mortgage applicants, but clients can also choose to select they do not wish to answer. So oftentimes we don't have race and gender data, well, any of the protected class data, but specifically for race and gender, we will also predict race and gender where it's not available. And we do that using a process we call geoproxy. It's using essentially a Bayesian approach that was evaluated by the Consumer Finance Bureau of Protection, or CFPB, that uses U.S. Census data as well as Social Security Administration data to infer race and gender from name and location. We're looking at a number of different alternative methods. The reason we rely more on BizG is because it's been looked at by the CFPB, but looking at other methods like using a machine learning algorithm to predict race and gender, since we have some of that data internally, to hopefully get better performance or better accuracy really with race and gender predictions. So I'm going to pass it on to Amaya to discuss in more detail about our evaluation framework.
Thanks, Lucia. So, I'm going to start by talking about our model evaluation framework and the approach that we take. So basically, in a nutshell, if I had to define it, it's very outcome focused. So we heavily focus on the model outputs and the actual outcomes when we are doing the testing, and we kind of have a model agnostic approach in the sense that, for example, if it's a classification problem, it doesn't matter if it's a random forest or a logistic regression model. Our overarching framework stays kind of consistent. So the first step, when we get all the model outputs, we have all the context gathered, we have all the data that we need, we check for representation across training sets and testing sets, and even post-production. In production, we try to ensure that there's consistency in the demographic makeups of the production population and beyond, to ensure that the representation stays constant. Then we also, this is the main part of the model evaluation bit, where we compare various different aspects of the model's performance across the various protected class subgroups that were mentioned earlier by Lucia. So this is the step where we objectively try to quantify and try to put numbers on the potential for disparate impact. So we quantitatively weigh the model performance, and then finally we package up all the results that we've seen through testing. We gather all the context, and we tie it up in a box with a neat bow, and we present it to our folks over at Fair Lending and Legal, who give their legal recommendations for the models used based on the findings. So as I mentioned earlier, we objectively try to quantify the model's performance and compare the results across various demographic subgroups. So what we use, the metrics, the numbers that we use are what we call the fairness metrics. So basically, the ideal fairness metric, the ideal characteristics of fairness metrics are that we want them to be easily measurable and quantifiable and comprehensible. We want them to be robust in the sense that we want to be able to be statistically confident in the accuracy of the results. We want them to be reproducible in the sense that we want to be able to easily reproduce those results and that level of analysis across test sets, across production sets, and beyond. So we want them we want the analysis to be replicable. And last but not the least, we want them to be relevant as well. That you can have, there's a long list of fairness metrics that you can use technically, but we want to ensure that we're using the right set and the most relevant metrics with respect to the use case and how the model is going to be used. So we want to ensure that we are looking at the right angles. So I kind of wanted to just give a sense, like I mentioned, what fairness metrics are, but I want to kind of give some examples. So here we're going to focus on some group fairness metrics for classification problems. So yeah, one of the angles that we look at is how well we're capturing the successes and how well the model is performing across various demographic groups. So one of the metrics that we use is called the equal odds ratio, which is basically the recall of a model. So how well it's actually capturing the the positive class that we're trying to predict, if it's doing that at an equal rate across various demographic groups. So this equal odds ratio helps us compare that bit of the model's success across various demographics. So we kind of set the baseline across various demographics, and then we weigh it together. So, and the other bit is we also like to compare the misclassification error rates. We want to make sure we're limiting those at an even rate as well. So one of the main metrics that we use for that, for classification problems, is the false negative rate parity, where we compare the false negatives that the model is making across various demographics as well. And another perspective from the model's performance evaluation that we look at is across various levels of the model scoring confidence. We try to see how well it's capturing the desired class that we're trying to predict. So we sometimes use the gain area under the chart, under the curve comparison. So we try to quantify the gain across various different scoring levels of the models across various demographic subclasses. So yeah, I thought it would be interesting to discuss some of the practical challenges that we faced as practical ethicists. So basically, the first thing that I wanted to mention is, again, fairness and ethics is a very difficult construct to define, and of course, fairness can take various different forms. Um, it can be distributive, it can be representational, it can be procedural. So defining what's fair and what's unfair and setting those standards is quantitatively also difficult. And on top of that, we work with a lot of different use cases and different models. So based on the use case, the lines can get even more difficult to define. So that's definitely one of the main challenges. Then secondly, defining thresholds is also difficult, as again, fairness is difficult to define. But on top of that, what the main thing is, we as everyone mentioned, everyone who spoke before me, that we heavily collaborate with legal, and one of our main functions is that as a baseline, we want to ensure fair lending compliance. So there's a lot of legal rubrics that we need to translate, and we to quantify those legal rubrics and making sure those can be translated into something that legal can understand. It's again, translating the statistical part of it is sometimes challenging, and there are some semi-arbitrary thresholds that are inherited from some of the legal laws. Like there's this one 4/5 or 80% selection rule, which dictates that the best performing the worst performing group among a subclass of a protected class should be at least 80% of the best performing group of the protected class. So again, that's a semi-arbitrary number, but again, statistically significant difference in numbers does not also always translate into legal disparities, right? So kind of to balance that bit, where we are making a lot of statisticals, we're ensuring the statistical rigorousness and the legal due diligence as well is important to balance. So that becomes challenging. Then building custom solutions and frameworks and implementing automation to operationalize ethical AI across the family of companies is also difficult for a few reasons. So, firstly, it's very, very resource intensive. There's a lot of personnel involved as well, where we need to work in collaboration with business partners. We need to work heavily with legal and the data science teams and the tech teams as well. And there's a lot of scale issues that we face with the amount of data that we have to deal with. So that makes it challenging. And then dealing with systemic bias and new bias patterns as well is one of the challenges, because again, as Brian mentioned earlier, we want to ensure equality, but we want to strive for equity. So um, just so ensuring equity is the first step, but to go for equity, we need to figure out how to address those biases and not just ensure equality, but make sure we are addressing those biases and using tech to promote equity. So it's a challenge to quantitatively and quantitatively operationalize equity. So that's also a big challenge that we've kind of tried to figure out. And finally, balancing ethical considerations along with business needs becomes challenging at times, because the business teams sometimes have like these um, really quick turnaround times, and they have like tight deadlines and timelines. So balancing the timelines along with the rigorous ethical testing that we do sometimes becomes challenging, and to make sure that we're doing enough to ensure that we're doing enough ethical due diligence within the stipulated timeframes becomes challenging a lot of times. So that's definitely one of the highlights as well. And yeah, that basically concludes our presentation for today. But yeah, we'd love to open it up for questions and conversation now. So thank you everyone for your patience.
I have a mic for question and answer. I will pass this over. Let's give them a hand.
Hi, David Corliss. David Corliss, General Motors. Wanted to ask a question about the algorithm you're using to estimate or predict to some extent race and gender based on name and location, and it's been through review, so absolutely good stuff. Man, I'd love to see the confusion matrix on that. In particular, I'm wondering if we've seen the same thing with facial recognition. I'm just drawing an analogy here. Here we're looking at name and location and inferring race. With similar to facial recognition, how accurate is it? In particular, does it vary with race and gender? Are we better at identifying, well, quite frankly, people like me, old white men? Do we get David Corliss recognized as male? Do we get it recognized as Caucasian more often than we get other groups of people? Is there variation by segment for that assignment, much as we see for facial recognition? Thank you.
Yeah. So again, yeah, that's a great question. Thanks for the question. So we normally do see that we don't capture successes in terms of how we're correctly predicting those races equally across various demographics in terms of race. There are skews, but again, the method that we're using is CFPB approved, and this is basically the baseline, industry baseline to predict the race of particular individuals. And we again, yeah, just to answer your question directly, we do not see like a level performance in that sense, but we do capture successes at a much better rate than obviously randomly guessing. So it basically, we've also made adjustments to algorithm in the sense that unless we have enough statistical confidence, we do not make a guess. We tag it as unknown. So we try to work with that ambiguity, and we've made adjustments to make the busy approach even more robust in that sense, and avoid those misclassification errors.
And just to add a little bit more, there's a lot of ways that you can increase that confidence with the location. Like, are you talking state, county, zip code, down to census tract? So we try to delineate as small of a group as we can to have that higher confidence when it does make that prediction, so that we get more accurate predictions than we get unknowns as well.
And just one more last thing quickly. So we've also been researching and experimenting how to get even better, and we are constantly adding upgrades as every other. I mean, we're trying to add upgrades to make sure our performance is doing even better. So yeah.
Any other questions?
Hi, thank you for the presentation. I was curious, so I know you list a lot of protected classes. Do you ever consider like the intersection of protected classes when doing all your measurements?
Yep. So basically we use those group fairness metrics that I mentioned, right? Those we test those across the subclasses of demographics as well, and we look at intersectional fairness, group fairness as well. So we look at intersections of race and gender, race, age, and gender as well, like a three-way intersection, and also like race marital as well. So we kind of work with all permutations and combination with race, and we do that additional level of testing as well. But that's a great question. Thank you.
Thank you. Any more questions there?
I think this question might be more of a speculation, but what are the ethics of attempting to predict race and gender when you've been not allowed to do it directly?
So basically, why we're doing it is to ensure that we are doing our due diligence in testing, right? This race and gender data that we're predicting and using, it's appended during testing. It's not used to actually build models. We make sure that the race and gender demographics and like the other demographics that we mentioned, those are not employed at all in the actual models used. So yeah.
Yeah, just to make sure I understood your question. So any of the protected class data is not accessible to any data science teams across the company. It's lockdown data that only our team has access to. The actual data, it's not prohibited to be used directly in models, and we also watch for proxy features depending on the use case. So for a use case that is like a marketing campaign, it might be more, it might show good enough performance or to allow for something like location, which can, be linked back to race or can be correlated with race. So we explicitly only use protected class information in evaluating a model's performance. It's not used directly in the prediction itself, the model prediction itself. Does that help answer your question?
Yeah, certainly helps.
Okay. I think we are up on time.
Yeah.
If we...
You can also have more questions later in
Yeah.
the discussion panel.
Yeah, we'll be around all day, so please come talk to us. Yeah.
Yeah, we're normally friendly, so you can just you can approach us whenever you feel like.
Another round of applause for the Rocket AI.